So let's see another video, question number 5 in this series. And here we have a square of dimension 80 and 80, out of which a semicircle has been taken out of radius 20, and that quarter circle has been added at the bottom side, left bottom side of the geometry. Means from the right bottom side, this quarter circle has been taken out and then added to the left bottom side. So we know our drill, what we have to do. So first thing is to assign the coordinates or reference axis, not the coordinate. So here this is my coordinate in y direction, and from the bottommost axis I am going to take a coordinate from in x-axis. So y and axis our coordinates has been defined, and I have already made the table. So we have three geometries. Geometry 1, which is a square of area 80 into 80. Let's keep the unit as centimeter. Then we have an area 2, which is being taken out, and then we have an area 3, which is being added to the system. So these are the requirements. Let's fill the vacant values. So area for a square is 80 into 80 is equal to 6400 centimeter square. This is also centimeter, and this one will be also centimeter. So here let me rectify this. Earlier I was centimeter, and then we have centimeter. So what is the area of second geometry, which is a quarter circle? So we know that for a quarter circle, area is given as pi r square by 4, which is nothing but pi into 20 into 20 by 4. This is 400, gets cancelled out, 10, 10. So my area is 100 pi, and same is for my area 3. Now let's find out the centroid, location of the centroid of respective areas in x and y direction. So first thing, my area 1 is in contact with the reference axis, leftmost part. So here for x direction, this x bar will be your half of the total length. So total length is 80 by 2 is equal to 40. And then yi, now remember there is a distance between this reference axis and the geometry 1, and this distance is nothing but of radius 20, because remember we have taken out this geometry and placed it here. So radius is going to be 20. So now first try to find out the location of the centroid with reference to its own extreme axis. So if height is 80, my location is going to be half of the height, that is 80 by 2, and then find the location between, measure the distance between the extreme reference axis of the entire geometry and the extreme bottom side or the bottom side of the geometry. So this distance is 20. So this gives us a distance of 40 plus 20, 60 centimeter. Now x2 is, remember, this portion. So we have made this for a quarter circle, both the quadrants x and y. The location is 4r by 3 pi from the flat side, this side. So from the arc side, this distance will be r minus 4r by 3 pi. So first, remember this reason. So first thing is the location of this centroid. We know that from the flat side it is 4r by 3 pi. Let's put the values, 4 into 20 by 3 pi, and this value will come out to be 80 divided by 3 pi, 8.48. So this dimension is 8.48 centimeter. Now if this entire length is 80 and this distance is 8.48, then the distance between these 2 points is going to be 80 minus 8.48. So 80 minus 8.48, 71.51. 71.51. So that's how we find out the value. So this distance will be 80 minus 8.48, this which is 5 2, which will be 5 2. Now y2, y means the location of centroid in y direction for area 2. So we know that from left flat side it is 4r by 3 pi. This value we have already found out. But remember, this location is from the bottommost part of the geometry itself. It is not from the reference axis. So my location will be 8.48 plus the gap between these two axes, which is 20 centimeters. So 20 means 28.48. And then x3. x3 means this location. Now this geometry is in contact with the flat side, is in contact with the left reference axis. Hence the location will be always 4r by 3 pi, which we have already found out, 8.48. And then comes this point. Remember, this is the flat side of this quarter circle. So this distance will be 8.48, but this entire height is 20. So this distance will be 20 minus 8.48. So I'm going to write this point will be 20 minus 8.48, which will give us 11.52. So 20 minus 8.48, 11.52, 11.52. Now let's start putting the values. X bar, remember second area is being subtracted. So I'm just going to write the formula for x bar, which will be a1 x1. Second area is subtracted, so minus a2 x2. Third area is being added, a3 x3 by a1 minus a2 plus a3. Similarly for y bar it will be a1 y1 a2 y2 similar. So let's put the values. 6400 into x1 is 40 plus, sorry, the second element is negative, so minus of 100 pi into 71.52, then plus of 100 pi into 8.48 divided by 6400 minus 100 pi plus 100 pi. This gets cancelled out. So we'll have the value. Let me complete the equation for y bar also. So 6400, y1 is 60 minus of 100 pi, y2 is 28.48, then plus of 100 pi, y3 is 11.52 divided by 6400 minus of 100 pi plus of 100 pi. So let's solve the equation. These things gets cancelled out, these things get cancelled out, and let's fill in the values. Let's try to calculate the values of x bar and y bar. So upon calculation we found out the values to be, for x bar the value came out to be 36.90 centimeter, and for y bar it is 59.16. Means this location, this point lies somewhere from a distance of 59. So 40, 59 will be something here, and x bar is 36.90, so half of less than. Means this is the location, this particular point is the location where your object is going to lie. So that is 36.9 and 59.16 centimeter, and this is your answer for this current problem. Okay, and this is perhaps the last video for the series. I hope the concept is clear, how to improve or improvise the formula based on the geometry. The steps are very simple. First, define the reference axis. Second, split the geometry into some reasonable shape, like for those kind of shapes for which you already know the location of centroid with reference to its own edge, and there will be no problem finding out the solution. So you need to remember the equations, need to remember the formula that we have discussed before, and then only you will be able to solve the answer for this particular chapter. So let me write the unit also. So that's all for this video. See you guys in the next one.